Hello, gentlemen. My name is Heinrich Munz. As you can see here, I'm a lead architect for Industry 4.0 at Kuka, at the Kuka group. So not Kuka Robotics, as you have maybe read in the brochure, but I'm working for the whole group. So what's the difference from the whole group? I don't want to make advertising here for Kuka, just to let you know what it's all about at Kuka. So we are the holding, or the Kuka group, and below that we have 4 different single companies, and one of them is Kuka Robotics. The other is Kuka Industries, then we have Kuka Systems and Swisslock, which we recently have acquired. And altogether we are making a automation powerhouse, so to say. So automation is our main business of the whole group. And maybe you know these things better. These are our robots. As I said, I don't want to go into details, and it should not be an advertising presentation here. And by the way, it's not about what Kuka is doing with OPC UA, as you have said, Sondern, but also more in general, what is going on at OPC UA in conjunction with new additional protocols, because as Martin Hankel said this morning, there is a gap for using OPC UA in our industry of industrial automation, and I'm fighting and working very hard to fill these gaps with specific technologies, and I want to talk about that today. So I want to start with what is Industry 4.0, because this is part of my title of this presentation. And by the way, the title of my presentation is Industry 4.0 Real-Time and Cloud Communication Standards, OPC UA over TSN and over AMQP. So I'm not only talking about real-time, but also about cloud communication, where we obviously, of course, don't need hard real-time, or cannot have hard real-time. So here is a nice picture from Beecham Research showing the several, as they call it, sectors in the Internet of Things. And as you can see here, there are a lot of different sectors: buildings, energy, consumers and their private homes, healthcare, industrial they call it, or I added manufacturing, transportation, retail, public security and safety, and the IT and networks themselves. And we already have heard about the IIC, the Industrial Internet Consortium, and I made bold the 5 areas where the IIC is covering. But as you can see, that's also not the full spectrum of the Internet of Things. And Industry 4.0, and this is very important to know, to recognize, and always to keep in mind, Industry 4.0 is only covering industrial manufacturing, only manufacturing. So it makes no sense to say something like Transportation 4.0 or Medical 4.0. That's wrong, because 4.0 was coined by the manufacturing industry, and so this is this part in here. This is what we are talking about when we say Industry 4.0. It's only manufacturing, using the Internet of Things for manufacturing. Okay, and in Germany, as you have heard, since I think 2011 or something, the German government have put a lot of effort into driving this Industry 4.0 standards, and here is the organization of several companies, and here 2 ministers are driving it. Then there is a steering body with top managers of several companies, and here are the working groups who are doing the real work. My colleague Martin Hankel and myself, we are members here in this working group of reference architecture, where the RAMI 4.0 came out, and also standardization and norms. And here number 3, this Martin also have mentioned, the security working group. So number 3 is a working group only for security. And by the way, there is also number 4 is only for legal questions, because Industry 4.0 opens or asks a lot of questions, legal questions, which must be answered. So this is the organization in Germany, and now I want to go into more technical details. So this picture, or the information from this one also Martin has explained a little bit. So this is the former automation pyramid, as we called that. And regarding communication, this very hierarchical organization now vanishes, and it becomes to a mesh network. And you can recognize here, unfortunately, sorry for that, that's German, this means real-time critical. So when we go to a mesh network where everybody can talk to each other, of course, we also have to keep in mind this real-time critical part, from the things up to a certain level of the controller layer. And so I try to put that in the light blue communications here. These are the real-time critical communications, and for that we are going to use the time-sensitive networking standard, which is an official IEEE 802.1 Ethernet network standard. So nothing proprietary anymore from a single company as legacy field buses, but this is now an official IEEE standard. Talking about legacy field buses, so I have found a nice diagram from the company HMS. They bring that out every year, where they put together the market shares of the several existing field buses which are relevant in our industry. I call that the M2M, machine-to-machine communication mess in industrial automation today. Why? Because there is a standard, a so-called standard, specifying 19 different field buses, completely incompatible and not interoperable field buses in only one standard. So what is this standard useful for? We need interoperability, and this is only possible if we only have one technology when it comes to the same job. You see here all the leading vendors of the field buses, and the right ones, the green ones, are the Ethernet-based field buses, and the blue ones here are the legacy field buses using what kind of transport layer ever. On that, even the cables, the physical connectors, everything is different. And as I said, interoperability is key to the success of Industry 4.0. So we cannot have all this or a similar zoo of protocols for Industry 4.0. Then we could not achieve the goals of Industry 4.0. And also what you can see here, these are only flavors of so-called industrial Ethernet field buses. What is missing here is a standard Ethernet technology. And why is this missing? Because it was not defined so far. There was no standard for how can I do hard real-time communication on standard Ethernet. But this has changed now, and TSN is the way out of this mess. TSN is a common standard for everybody from the IEEE, not from a single company, to do hard real-time communication on standard Ethernet. And here is the website of this time-sensitive networking task group, and as you can see on the URL, it's an IEEE 802 organization. TSN is the successor of AVB, audio-video bridging, so this is where it came from, but in the meantime it's much more than only audio and video. It is also used inside cars. A lot of automotive vendors are going to use TSN in the car for real-time communication inside the car of the different components in the car. And of course you can imagine if every car in the world in the future will have TSN inside. This will very aggressively lower the price of the components, the switches and the end nodes and so on, because of these very, very high volumes. And finally, now we are also looking into TSN in our industry of industrial automation. Okay, so what is time-sensitive networking? And I don't want to go into much details here because this is not a webinar, not a seminar for TSN. There are a lot of sources which could do that better than me. I just want to give you a little overview. So TSN is not a single technology, as you maybe have seen from other field buses and so on. It's about, it's more than 10 sub-technologies, and some of them are listed here. And as you can see here, they have very funny abbreviations. QC, whatever, and ASREF, and QCC, and CB, and QCI, and whatever. So I don't know who has created these abbreviations. For me, they are completely senseless, but it is as it is. And here are the explanations what it is. And in our industry, we mainly need this three with the priority one. Only three of those sub-technologies we need for doing what we have to do in our industry of industrial automation. Number one is time synchronization, so each node has the same, absolutely the same time in microsecond accuracy. So this is the goal, and what ASREF can do is to synchronize the clocks, not only the human real-time, but also the clocks are completely phase equivalent in every single node. This is time synchronization regarding the RSREF standard. Then there is, and by the way, this is a successor of the good old IEEE 1588 time synchronization protocol. PTP, maybe you have heard about, Precision Time Protocol. So, and then number two, what we need is a time-triggered scheduling, QBV. This means that at a certain point in time, there is a transportation window reserved for high critical telegrams. And exactly when this window comes up, then the high priority telegrams are allowed and should be sent through the network. And all the switches in between know that exactly at that time they have to let this telegram go through and of course block all others. So this is roughly how QBV works. And finally, QCC is some kind of a configuration, because this network has to be configured, dynamically configured, because if a new node comes in, it has its requirements, and it tells the network, please give me this high priority prioritized time window. Please give me a certain bandwidth which I can have all the time guaranteed, and so on. And this is QCC. Okay, so this was the technology for TSN, and then let's take a look what is going on with this technology, because it's so popular and so agreed, everybody has agreed that we are going to use that in the future. There are in the meantime several groups coming up like mushrooms who are now working on this standard, how to use it in our industry. And one of them is the TSN, IIC TSN testbed, which was set up first in Austin, Texas. And this is how it looks like where the people are working in Austin, and this is how it looks like on a show. For example, I think this was, I don't know, Hannover Fair last year. Then there is the OPC UA TSN testbed at the Fraunhofer IGCV in Augsburg, and my colleague Mr. Dominik Romus after me will present this testbed. Then there is a so-called OPC UA TSN Shaper group. It's a spin-off from the IIC testbed, from this one, pushing only OPC UA over TSN, because the IIC says we don't care about the higher layer protocols. We welcome everybody who can do whatever they want over TSN. But here the Shaper group says we want to concentrate only on OPC UA over TSN. And the latest information, this is very, very good news. Also the ProfiNet Industrial, ProfiNet International, and everybody knows that Siemens is a main sponsor of this group, has decided to put, number one, ProfiNet on top of TSN, but number two, and this is the good news, in addition and on the same cable to have ProfiNet on TSN, they also will have OPC UA on TSN, doing hard real-time communication. So we can have a mix of OPC UA on TSN plus ProfiNet on TSN. And this is a perfect way to do a migration path, because we can use the older technology plus the newer technology, and the market will decide which one will win or fade out or whatever. I don't care about that. The main thing is that it is possible. And as I said, there are working groups to take care of that this really will work. And yeah, as you can see, this is a little part of a slide from the ProfiNet International. It says machine networking with OPC UA. OPC UA for horizontal controller communication using synchronization with TSN. And of course PubSub, because without PubSub there is no real time. Okay, I put together all these different groups here in a Gartner hype cycle curve, starting with the oldest, and this is also good news. There is, since a long time, several years, there is already a working group within the OPC Foundation who are taking care about PubSub over TSN. So this is the most, the oldest. And so they are already now, since many months, in a trough of disillusionment, because it's hard work to do that. Then the IIC testbed, they are the second oldest, and well, they are also working right now, but doing still a lot of marketing hype. The OPC UA TSN Shaper group, as I said, is a spin-off from those here. The LNI 4.0 TSN testbed is still in the founding phase. We started in spring this year, so we at the moment are only in the marketing phase, but technology will follow. You will hear more about that in the next presentation. Then there is a TSN for Automation group, which is from the University of Stuttgart. A group which has been founded, and as I said, finally the ProfiNet International group. They also have now gone into this game to make use of OPC UA over TSN. I go a little bit more into LNI 4.0. What does LNI 4.0 mean? What is this, and how does it fit into the platform Industry 4.0, which is a German initiative? And you can see here on this very good slide that Industry 4.0, this is the platform in the middle. And here the different organizations, they bring technology input into the platform. In the LNI, there should be set up test beds. So in the LNI 4.0, we are doing tests. So we want to see if the technology we are talking about here only, we want to try out them. And so this is where the test beds are taking place. And finally, if this is everything is okay, and we say, yeah, okay, that's a good standard for Industry 4.0, we should recommend that. Then we put it into the Standard Council, Industry 4.0, Standardization Council, excuse me, for Industry 4.0, and these colleagues, they are putting it into international standards like IEC and so on, and you have heard from Martin Hankel all of these activities. And I put here also the relationship to the IIC. As I said, the IIC is not only concentrating on one sector of the Internet of Things, but on 5. And one of the 5 and the middle one is manufacturing. And so we have agreed with the IIC that we in Industry 4.0, we are concentrating very deeply only in industrial manufacturing, while the IIC is more or less a marketing organization to push the Internet of Things in all verticals, or in the 5 verticals they are supporting. As you can see here, Industry 4.0 since many years is not only a German initiative anymore, and also, as you have heard from Martin Hankel, we have a lot of relationships to other countries in the meantime, and we try to collaborate with them and make that global standard. Okay, here is a picture from Professor Walster, which is nearly 4 or 5 years old. So he had at that time the broad view into the future, how a communication device of the future has to look like. And this is the stack, the OSI ISO 7-layer stack, which have to go into every automation device of the future. And it's similar to what Martin Hankel have shown you before. We have Ethernet on the lower layer, we have IP, we have OPC UA, and we have the so-called semantic service description. Sorry for the German language. I've only got that from Mr. Walster in German. But it's easy to translate. These are the semantic service descriptions. So to speak in OPC UA language, these are the companion specifications of the device. But as I said before, we have identified some gaps. So on layer 2, we need TSN in addition to get the hard real-time capabilities. On layer 5 and 6, we need PubSub in addition. Well, this is under its way since a few years, I think, the PubSub enhancement for OPC UA. But at the moment, we are looking very deeply into AMQP as an additional transport mechanism for OPC UA. And this is very important. It is still OPC UA with the complete function set of OPC UA only being transported via AMQP. And it's not, and this is very important what you have said, I would put something in addition. It's not only PubSub, it is also client-server over AMQP. Why is this so important? If we would use only PubSub via AMQP, we would lose most of the features of AMQP. If we don't have the client-server principle in the, as well, we would lose browsing the information model of the devices. We would lose subscriptions. We would lose historical data access, whatever. It's much more than only telemetry, getting data out of the devices. But I come to that in a later slide. Okay, so TSN on layer, I talked about that. Okay, so same picture here as you have seen this morning already, and I have tried to put exactly in here where OPC UA will go into with the enhancements of TSN and AMQP. And yeah, I can go over this pretty soon because you've seen that already. And now I want to put into this cube where OPC UA is located. So it's located here in the instance of the devices. And as I said, on the lower level, when it comes to hard real-time control, we need the enhancement of TSN, but only as a transport layer for OPC UA. So it's not replacing OPC UA with TSN, it's enhancing OPC UA with TSN. And the same thing is true on the upper layer when it comes to cloud communication. We want to use AMQP as a transport layer for OPC UA, but still keeping all the functionalities of OPC UA, including client-server. Not only PubSub over AMQP, also client-server. And from a technical standpoint, this works. We already have proven that. And so, yeah, on the integration layer, there are the legacy field buses, but although these legacy field buses, they have to be integrated somehow into this new OPC UA world. And the Fieldpass Organization, in the meantime, they already have understood that this is the way to go. And the Fieldpass Organization, in the meantime, already have a lot of working groups started how to migrate the information models and so on from the dedicated field buses to OPC UA. And I have some examples here. Circus, OPC UA companion specification for Circus. Then there is a PowerLink organization. Then ProfiNet International. I talked about that already. Then there is EtherCAT and OPC UA. There is ODVA with Ethernet IP and OPC UA. There is CC-Link and OPC UA. There is IO-Link and OPC UA. And the last I have found, there is CAN Open and OPC UA. And all these fieldbus organizations are going to specify how to transform data and information from the underlying field buses, which will still be there for several years, of course. OPC UA, including TSN, will not replace the field buses, at least not within the next 1 or 2 years. The market will decide, and the products of the suppliers will decide, depending on how good they are, if this ever will happen, or if we will have the field buses always in addition with OPC UA. So let's see what's happening here. Then here is a very nice picture from the EtherCAT technology group, the ETG, from I think 2015 from the SBS IPC Drive show, showing how EtherCAT works together with OPC UA in future scenarios. And so this is a machine or a controller or whatever, a robot, here it is. As Martin Hankel has said, here is a management shell, which, of course, in a first step is an OPC UA server, or can be an OPC UA server, when it's directly in the device. When it's directly in the device, then there is an OPC UA server. And southbound, of course, these machines internally can talk whatever they want. But to the outside, northbound, they have to talk OPC UA, because this is a common standard. There is a very, very exciting information from the last technical committee meeting a few weeks ago in Frankfurt. The ETG will define a profile how EtherCAT telegrams shall be transported in TSN networks. So EtherCAT, the original EtherCAT telegrams, can also be used in the open TSN network. So this means OPC UA plus TSN and EtherCAT also can be on net layer up here, because it goes through the TSN networks. And this is not to replace EtherCAT by TSN, but to enhance the usage of EtherCAT, not only in closed EtherCAT segments, but also in the open Ethernet TSN-based network. And now just imagine an EtherCAT device or a Kuka head just being connected somewhere on a TSN switch. You directly can put an I/O clamp onto a TSN switch. And you need, of course, an EtherCAT master somewhere in the network, and you can use all of the existing EtherCAT devices with this technology. And of course, as with ProfiNet, this also will be compatible with using OPC UA on TSN. So you can here again and also have a migration path to use existing technology and use future technology. And you decide, or your customer decides, when to use what. As I said, they are coexisting, and this is a migration path. Coming to the work of the German Machinery Association, which is the VDMA. But before that, I just want to mention the ZVEI, which Martin Hankel have presented already. Unfortunately, this is an older slide. I only got the German version, excuse me. But you have got the link from Martin Hankel where you can find the English version, stating that OPC UA must be part of an Industry 4.0 device of the future. And now I come to the activities of the VDMA, and you have heard that also before, that the VDMA is now going to be responsible and take care for the companion specification of the dedicated machines in Industry 4.0. So all of their members are going now to found several working groups and create all together. Competitors are sitting together and creating a common information model. And one of the first we have started is the robotic companion specification. There is also a companion specification. This is the oldest one for injection molding machines, vision cameras, and IIS, intelligent assembly systems. These are also working groups which are already running. FS means functional safety. This will come in the future. So we also are creating a companion spec edition in the specific devices for functional safety. And here are the planned ones. So electrical drives on 14th of November. There will be the working group will be founded to define a OPC UA companion specification for electrical drives. So how can we control electrical drives with OPC UA TSN? This will be defined in the VDMA, 15th of November this year. Then other things we want to do is I/O sensors, IO-Link, and so on. CNC, there already exists a companion spec for the CNC machines, but we want to harmonize all of these specifications so that they are familiar with each other. And this is a job for the VDME. Okay, and then I finally, and this will be my last point, is look into the Cloud Federation, transporting OPC UA via AMQP. And here is a use case scenario, which is pretty much probably the most scenario you will see in the future. Because the slides you might seen today, or you see nowadays, or probably you have created your own, always shows the devices below and one cloud up there. This is not a realistic scenario. There will be not only one cloud. There will be several clouds in the future. And at least in bigger companies, there will be what they call a customer's production cloud. So imagine a big automotive vendor like Daimler or BMW or Volkswagen and so on. They never will allow that the data from the production plant go in a first step somewhere else but into their own cloud. And they will have their own cloud. I know that. They are already now setting up a production cloud for their plants. And this will be only one cloud for all the production plants, for example, for Daimler, all over the world. And the FIST formula is what they tell us as suppliers. Okay, Industry 4.0 is fine, but there is one rule which is non-negotiable. And this means all the data which are coming from the plant, from the things, at first have to go via the edge or not into our cloud. Though this arrow here, this is very, very important. The data go at first into the production cloud of the manufacturers. Then the manufacturer decides which data go into which other supplier clouds. Because, of course, they want to give us as Kuka the data from the Kuka devices. And they want to give to supplier number one the data of the welding devices or whatever. But what they never, never, ever will allow is to give the combined data into one of those supplier clouds. Why not? Because if somebody will have all the data, this one can directly see what is going on in that plant completely. And the big customers will never, ever allow that. And so they have the need here for a kind of distribution of data. And this is where Cloud Federation comes into the game. Or maybe an easier way to imagine that is cloud routing, as I sometimes call it. And this will work as following, but let me put here a few requirements. First, requirement number one, for Industry 4.0 we do not only want to do data collection, not only telemetric data with PubSub. That's by far too less. And number two, requirement number two, there will be more than one cloud, as I have shown here. And they will be cascaded, one cloud after the other. At least the customer's production cloud will be the first one, and then from there it goes into other supplier clouds. And so this, and there is a second point. We also want to do out of the clouds, plural, several clouds, we want to do browsing of the precious OPC UA information models which are down there. There is a very precise information model which the VDMA has created. And of course, I want to have this information model also here in NetCloud, or the customer want to see this information model. And this information model goes away if you are using MQTT or REST or whatever. It only will be kept if you are using still OPC UA client server, but with another transport protocol. We want to subscribe OPC UA data directly from the servers. We want to call OPC UA methods. So it's very important message for which we need for our service-oriented architecture, SOA. We want to keep this possibility to call methods down there in the devices, also from the cloud. And this will go away if you are using only PubSub. This will go away if we are using MQTT. This will go away if you are using REST. And so it must be OPC UA with a transport protocol. And so, yeah, we want to do software updates and many, many more OPC UA stuff. And this means this is not possible with PubSub only. And this also means we have to keep the OPC clients also in the clouds. And this means that the final scenario looks like that. We will have the OPC UA servers in the devices. We will wrap around the OPC UA server an AMQP client in a device. Every device must have an OPC UA server plus an AMQP client. And then we can go through the firewalls, because this client, the blue client, sends its data to a broker, an AMQP broker, or, and this is a benefit from AMQP against MQTT, it is route-able. We can route AMQP messages through the cloud. So the client connects to the broker, and then I can put an OPC UA client also wrapped with an AMQP client here somewhere in the edge. Or if this is used as a relay, then there is a broker, the AMQP broker. And then I can put an OPC UA client here in the production cloud of the customer. And this is a very big benefit, using this relay orchestrated and configured by the user, by the customer here. He can send, relay the fitting data to here to this broker, and where another AMQP client sits with an OPC UA client in the Kuka cloud or in the other supplier clouds. And so this means I can use my client in my cloud to directly connect to my OPC UA server in my robot. And everybody else can do the same, directly connecting to the OPC UA server with client-server technology, not only with PubSub. And finally, I also can imagine, I don't know if this makes any sense, but I'm sure there will, some use cases, to put an OPC UA client with an AMQP client directly into a smartphone. And I directly can access with an OPC UA client in my smartphone, I can direct access an OPC UA server somewhere in the world. And that's it. Thank you very much.
Yes, thank you very much indeed. Questions for Mr. Munz?
Hello, Teemu from Siemens. About the AMQP, I guess it won't be time-sensitive data anymore?
No, because at the moment where you go in over firewalls or into the cloud, you cannot talk about real-time time-sensitive anymore.
Yeah.
Because you lose the deterministic going into the cloud today. Maybe in 10 or 20 years you will have deterministic clouds. I doubt that, but okay, a lot of people have done mistakes here. But what I want to say, of course you can have timestamps here, and you can access these timestamps from over the world. But the communication here through the cloud is not deterministic real-time.
Yeah, and is the communication method kind of broadcast or multicast when the data changes? Will it be simultaneously on every relay broker available, or is it still the server communication?
Okay. Yeah, and this is what I tried to say 100 times. It's not multicast. It's not pops up. The communication between this client and this server is a good old client-server-based OPC UA, which we have had for 10 years. We don't need pops up for the cloud! Exclamation mark. We don't need it! We need pops up only for TSN. Okay? Oh, got it. Please, Peter. We can have pops up in addition as soon as this communication is established using client-server. Of course, then we can say to the server, okay, now please publish. But for what? I have subscriptions. I can do exactly the same thing what pops up could do with the good old subscriptions. Okay?
Okay, thank you.
Any more questions? Yeah, I was very happy to hear about this as well. I haven't followed very closely what's happening there at the PubSub TSN group or with the PubSub group in general. We are implementing it to our toolkit at the moment, but I also kind of get myself a bit out.
Yeah.
And the reasoning behind is something I've seen that people have been working on these PubSub technologies for a couple of years, and,
Sure.
and they're still struggling to get it finished because there are different use cases, different scenarios, and different technological challenges there.
But coming back to that point, this is very important. This also was a question this morning. Of course you can do it somehow, but the very important difference is what we are doing here. We are trying to establish here a standard which will go into all the standardization councils and so on. And so this would be the preferred way how to do it. Of course everybody, Kepware can do it with REST. You can do it with PubSub. Whoever can do it how they want. But this will not be the standard. We prefer, or we are trying, we are working on that. We have to do some tests and so on in the test bed. Mr. Romus is already waiting. And if these tests all are gone and we agree all on that, then this could be the preferred standard how to communicate OPC UA into the cloud.
Yeah. Thank you very much. Yeah, we could continue this discussion for the rest of the day, but we have to move on. So the next presentation from Dominic Rormus, please.